Today I'm gonna present to SOK a taxonomy for layer 2 scalability related protocols for cryptocurrencies. I choose this paper because I want to summarize the trends in the field I'm working on and organize previous works. The technical challenge of increasing the number of TPS of blockchain system is urgent and is closely related to the inner workings of the system itself. It is common to divide the approaches to increase the TPS rate in three cases. Layer 1 is about network infrastructure, Layer 0 is about the network infrastructure, and Layer 1 is about the consensus protocol, and finally Layer 2 is about the off-chain channel or protocol. So in this paper, author focused on Layer 2 protocols and they propose taxonomy for all the components of the layer 2. So this paper contribution is they provide a taxonomy for the layer 2 stack and devise a taxonomy with classification for the three cited levels. First, off-chain construction, second, payment channel network, and third, network management. And they provide comparison on the body of work in level and security and privacy preserving construction. So they provide type of problems between the levels. And they organize the different sets of protocols in three levels. Off-chain channels, construction for the channels themselves, how it's about how the node relying on the transaction design of a cryptocurrency. Second, network. This is about the concatenating existing pairwise channels or establishing network or more than two nodes right from start. Finally, network management is embrace the protocols and algorithms that maintain the channels and network of channels. Off-chain, this is functions on each level. Off-chain channels provide making a payment and keeping each state. In network level, their function is special techniques are required to list. It is also necessary to carry the payments themselves. And network management, they provide functions routing, rebalancing, and stability, and anonymity or privacy. So this is main part of this paper. You can see that the table consists of three levels, and each level consists of some function that the level provide. The off-chain channels consist of function that state duplex payment and simplex payment and probabilistic payment. And network section consists of construction, and network management consists routing, rebalancing channels, and channel stability, anonymity, and privacy. They categorized previous research achievement into the categories they set. I will explain one by one. So in the off-chain level, they can be in off-chain levels state, and these can be categorized as payment channel. So this is basic of typical channel phases, and in setup phase is two parties lock fund into the blockchain, which the sum of fund is the capacity of the channel. In payment phase, the parties can exchange funds without interaction regardless of the confirmation time of the blockchain system. And in closing phase, when the two parties decide to close the channel, they publish transaction accordingly into the blockchain, and they must publish recent off-chain transactions, which means current state. But the sum of parties can publish its previous state. So in closing state, any parties can also trigger the dispute state. In dispute state, user can start a dispute in the case the other party do not follow the protocol. For example, they can publish previous state. So this is first concept of the payment channels, simplex payment channel. They have only one direction, and payer can only pay to payee, and this is initial version of a simplex payment channel. So in that concept they use Sycnum, which has been disabled on previous time, and this is about probabilistic simplex payment channel. So in this protocol, the payer sets an escrow address and put an amount of coin into it, and after the payment is performed, the payer can potentially use the same escrow to pay another merchant after some time has passed. So, and moreover, the payer sets up second escrow in parallel such that in case of misbehavior, the payment will be burnt by the verifiable third party. So this is earliest proposal of payment channels. And finally, this is duplex payment channel. As you know, both parties can allocate funds into their mutually shared channel, and there are many researches about this. For example, Lightning Network, duplex channels proposed by Decker, and Lightning Network, etc. So this is a duplex channel in punishing payers mechanism. In each transaction in Lightning Network protocol, each participant creates commitment transaction with revocable delivery transaction. So and they create each transactions and each signs others transaction. When they exchange message, Alice and Bob each exchange the revocation key used in commitment transaction 1 to abandon the transaction in C1. So, and in this case, even if Bob submit a previous commitment transaction to the blockchain to make more money, it won't be his own right because RSMC's time lag is locked. And during this time, if Alice submits a breach remedy transaction to the blockchain and probes Bob's misbehavior, Bob's assets are owned by Alice. And this is duplex payment channel in hardware-based approaches. So you can see this is protocol of T-chain, and T-chain using trust execution environment and introduces full duplex payment channel framework between mutually distrusting parties, assuming that they are equipped with T's. In this protocol, each root of trust is T, not blockchain. So in dispute case, they do not need any monitoring system or watchtower. As you can see in T-chain, they can easily process disputes atomically and safely. And our protocol InstaPay also can belong to this category. And this is concept of channel factories. The confirmation time for the channel setup phase may still be unacceptable for micropayment because there are blockchain's confirmation time. So the relaxation in this requirement is the motivation for the creation of channel factories. So the core idea is to introduce a layer between blockchain and payment, and this translates into a step where a group of collaborators jointly fund a factory. And in this concept, any new pairwise channel can be created among the initial users. From this point, open communication between collaborators, hence creating channels. So I don't know actual mechanism for this, but I think each mechanism seems like T-chain or no cost. And this is state channels. In this work, the channels are built based on special instructions for transactions. Smart contracts, as in Ethereum, enable more complex off-chain structures. So the smart contracts can be used to store the state of the channels other than just the fund distribution between the two parties. So they used for card game or other state. And this is also example of state channel, no cost. So no cost is also example of these state channels, and all participants in payment hub can send any participant in payment hub without creation of its payment channels. And trusted third party records all the payment and each state, and it periodically commit each state to blockchain. And now this is a network level. So in this level, the concern is how the payment network can be established in contrast to how it is managed. And pairwise payment channels can be concatenated in several nodes to form a payment network, which can enhance even more scalability of a system. And between two nodes do not necessarily contact each other to open a channel. So this is HTLC and conditional transfers. So you can see this figure. And nodes can execute a payment atomically on a set of channels using HTLC. And a payment can be routed across a sequence of a channel without payee having to create a channel between themselves that would require committing transaction onto a blockchain. So in this figure, node A wants to send coins to C, and as the first step, C compute the hash value on the arbitrarily chosen random number X and share it A via direct channel. And the actual transaction is carried by A sending the funds to B and using their mutual channel with the extra condition that node B shows the secret value X. And the node B handles the fund to C in a similar fashion, relying in their mutual channel. And this concept is used by Lightning network based channels and Sprite, Raiden, or Decker, or Perron. And this is about mitigating dispute-based cost. So the Sprite protocol is designed for Ethereum smart contract and has the goal of reducing of time complexity of resolving a dispute. The whole protocol is similar to HTLC, but in Sprite they can reveal secret X to secret registry contract. So this is same as Raiden network. So what is difference between the Lightning network and Sprite protocol? This difference is from the blockchain platform, which means different smart contract. And I think this assumption cannot cause the wormhole attack that I will explain. In network level, there are research about generalized state channel. So these are approach to construct a more general structure over off-chain channels, and the former treatment virtual channel, which allows the creation of multi-state channel across a sequence of single hop state channels. And these are proposed by Perron and the generalized state channels published in 2018. And the advantage of this concept is that it eliminates the involvement of intermediate nodes and reduces on-chain transaction in multi-hop transactions. But the disadvantages is that the dispute processing becomes more complicated. I haven't figured out this concept yet, but I will figure it out by reading papers. And this is one more attack on payment channel networks. So this attack is carried by two colliding nodes within the same payment route, and the two nodes share pre-image value of the HTLC while keeping the nodes in between them oblivious to the payment condition value. Consequently, in the point of view of the nodes in the extremity of the path, the payment is carried out, but while the node in the middle of the path see as it has failed. So in this figure, A wants to send 10 BTC to D, and each hop fee is 1 BTC. When the reveal pays, D send each secret to X to E2, and E2 directly send each secret to E1 without sending each secret to C. Therefore, in the point of the C, in the point of view of the C, the payment is failed. Thus, HTX is timed out, and E1 and E2 can get C transaction fees. And this section is almost level in their classification, and arguably this level offers a greater variety of technical issues in comparison to the other level. So routing, rebalancing channels, and channel stabilities, and anonymity and privacy. Okay. In network management level, there is a routing problem. So in payment channel network, any participant can do multiple payment, which is using existing payment channel between the participants. So what's the problem? So how to find payment path? These routing challenges are similar to computer networks. However, there are important differences due to payment network nature. First is routing should be scalable, and the amount of the fund that can be routed through a path depends on the capacity of the channels with the lowest capacity on the path. And the node within a path can be either controlled by malicious adversary or spontaneously go offline. So in existing solution, often the author says often routing algorithms rely on landmarks, but I disagree with the sentence because I found a lot of routing mechanisms that doesn't use the landmarks. But in case of Silent Whispers and Speedy Murmurs, which was published in NGSS, they use landmark mechanism. So the landmark node is publicly known as which means semi-honest. And in Silent Whisper, all routing is done through landmarks by computing the shortest route. And in Speedy Murmurs, they using landmarks as root of respective spanning trees are computed to create an address space within the network. And based on this address, they find the shortest distance between nodes. Finally, they conclude some path. And the other case without landmarks, Honish and Weaver pioneered the adoption of techniques from mobile ad hoc network, and there are many study cases about adopting existing network solution. For example, Spider. And this is routing technique in splitting payment. And payment can be split up into multiple smaller payments and routed through the multiple route. So in this routing mechanism, sender chose the number of key paths and split each payment value and send to a receiver. Today, many researchers adopt this mechanism to each routing mechanism. For example, Speedy Murmurs, AMP, Split Payment Protocol, Spider, Flash, etc. And this is a channel rebalancing mechanism. Given the limited capacity of the channel, it may be necessary to rebalance a set of payment channels to avoid the channel turns into a simplex one. So you can see this figure. We can conclude the needs of rebalancing. To resolve this problem, Rami Khalil suggests Revive protocol at CCX 2017. And this is about the channel stability. So channel between two nodes assume that both stay online on the duration of the channel. So to resolve this problem, receiver can custodian node, sometimes also referred to as watchtower, to watch over their payment channel while they are offline. And so this is watchtower. So they concern about our nodes acting badly. So in PISA, the custodian can dispute malicious commitments of other peer while each customer is online. And also there are similar concepts in Raiden or Lightning networks. And additionally, I didn't put slide about privacy and anonymity, but simply speaking, there are mechanisms for speed mummers which generate anonymous address and onion routing schemas in Lightning networks. So this is final remarks. In this paper, they provide a major review of the body of work on payment channel networks and related protocol for layer 2 solutions, and they highlight which work on routing protocol and trend on network construction protocol for the network level, etc. Thank you. Do you have any question?